you see, the forklift just detected the load with the ultrasonic sensor within 9 inches. And now it's proceeding to the yellow. And when it gets to the yellow, you'll use the color sensor to pick up the load. And now the last sensor is the IR sensor, which communicates with the RCX. Now I'll be giving it to Brendan.
Thank you, Anoop. And now talking about the safety zone in the arm. As you see, our safety zone's lid just rose because the forklift sends a Bluetooth message to our safety zone, and the motor in our safety zone goes up, and a touch sensor in the back stops this from breaking apart. So then our forklift continues forward following the black line, and at the red marker, it lowers, and the infrared right there tells the crane to pick it up, drop it down. And over here, when it Bluetooth on, this valve opened and water is coming here for the effect of dry ice. But everything is going to reverse back. And a touch sensor is right here, so when the lid closes, it stops. And I'll be giving it to Poojan.
Thank you, Brendan. I'll be talking about the NXT safety zone and the RCX crane. In our RCX crane, we used one motor for grab, a motor for vertical movement, and a motor for horizontal movement. And we used no sensors. And also, this robot will receive a message from the NXT forklift when it comes towards the red. And also, this is about the NXT safety zone. We use 2 touch sensors. One touch sensor, when the lid goes up, it touches this touch sensor, which tells the motor to stop. There's a touch sensor over here at the bottom that tells the motor to stop when this lid hits it. And also, we use 2 motors. One motor for making the lid go up and down, and a motor for turning the screw, which opens and closes the valve.
Hi, I'm Sam. I program the control system for the quadricopter. So it's based on PID control. So the idea is we have sensors and we have outputs, which are the motors. And so we use the sensors to determine how quickly the motor should spin to maintain the kind of control that we want. So for example, we have a gyrometer and an accelerometer on there. So we can use those to determine which way is down, how quickly we're rotating, things like that. So let's say we're rotating toward this direction. So we're pivoting like that. We would want to increase speed to these 2 motors and decrease speed to the other 2 so that the quadricopter will stabilize itself. So we do that through PID control, which is based on 3 components, P, I, and D, which stand for proportional, integral, and differential. So proportional control means the farther that the sensor is from the position that we want to be reading, the more we have to correct. So if the accelerometer shows that we're tilted very large angle, then we would increase speed to these 2 motors significantly and then significantly drop the speed of the other 2. And so integral control is summing the deviation of the set red values from the goal values over time. So if we're constantly tilted a slight amount in one direction and we keep correcting it, but maybe the wind keeps blowing us the other direction, we would notice that, and then the quadricopter would compensate for that so that we would maintain a stable position. And then differential control is based on how quickly the values are changing. So if we are tilting back toward the stable position, what we do is notice that. We don't want to overshoot the stable position. So the differential control tells it to not go as quickly so that we maintain stable position rather than overshooting and oscillating.